Solving systems using elimination is typically a class favorite because there's just something therapeutic about being able to completely eliminate a variable. So let's take a look at a system that we could solve using elimination. Let's say that we have 2x minus y equals 12 as one of our equations, and 2x minus 6y equals 2 for the other equation. The idea is that we're going to eliminate or get rid of a variable. We do this by having a positive and a negative of the same variable. So if we have, a 7y, we would need a negative 7y in order to be able to cancel it out. We're going to use an old arithmetic trick called stack and add. So if I were to look at these two equations in my system, the first thing I notice is that I have two of the same term. 2x exists in both of these equations. I would like one of the 2x values to be a negative so that I could eliminate the x term. So I'm actually going to multiply this bottom equation by a negative. So negative times 2x is a negative 2x. Negative times a negative 6y is a positive 6y. And negative times 2 is a negative 2. Now I no longer need that statement. Instead, I'm going to take what I have left and stack and add this information. I'm going to remove the bracket so it's just, well, it's not going to let me remove the bracket, so I guess I'll just leave it where it is. Alright, so if we look at 2x plus a negative 2x, that's the same as saying 2x minus 2x. Totally cancels. 2x minus 2x is 0. So now let's stack and add what we have left. Negative y plus 6y is 5y. And 12 plus a negative 2 is the same as 12 minus 2, or 10. Easy, right? We'll divide both sides by 5, and we know that y equals 2. Once we know this, we can plug y back into one of the two equations and find the x value. I'm going to pick this one because it's easiest to work with. We have 2x minus y equals 12. So 2x minus the y value that we found equals 12, and we found y is 2. So 2x minus 2 equals 12. Add 2 to both sides. 2x equals 14. Divide both sides by 2. X equals 7. So what is our solution to this system? When x is 7, y is 2. Nice, right? Okay, let's do another one of these. So the whole idea is that we need a positive and a negative of the exact same term. So let's look at another system. In this case, we have 7x plus 3y equals 1, and 3x minus 3y equals negative 21. Now notice in this case, we already have a positive and a negative of the same term. So we don't need to do anything special to these equations. We can simply stack and add them. So stack and add. So 7x plus 3x is 10x. 3y minus 3y is 0y. The y term is eliminated. And 1 minus 21 is a negative 20. Divide both sides by 10, and we're left with x equals negative 2. So we can take this x value and plug it back in to either one of the original equations. I'll just pick the top equation, 7x plus 3y equals 1. And we'll plug the x value we found in for x. So 7 times x plus 3y equals 1. And the x value we found was a negative 2. Seven times a negative 2 is a negative 14. So if we add 14 to both sides, 3y equals 15. Divide by the coefficient. Y equals 5. So the solution to this system, when x is a negative 2, y is 5. I mean, really, you've got to love solving by elimination. Let's do one more solution by elimination. Let's see if we can find one that may be a bit more challenging. Okay, let's look at this one here. So here's our system. 12x minus 4y equals 24. And 9x minus 3y equals 18. So when we look at this, we have to choose. Are we going to eliminate the x term or the y term? Either way, we're going to have to manipulate both equations. So it really doesn't matter. We could get a positive and negative of the same x term, or a positive and a negative of the same y term. I think I'm actually going to try and eliminate the x term. And I'm going to do that by multiplying by a fraction. You might want to think of it as dividing, so that I can work with smaller numbers instead of bigger. Because when I look through here, I see that all of those values have 4 as a common factor. All of these values have 3 as a common factor. So I think I can reduce this down and work with a little bit smaller numbers. So I'm going to multiply this top equation by 1/4. So I'll reduce it down to be a fourth the size that it is now. 1/4 times 12x is 3x. 1/4 times a negative 4y is negative y. And 1/4 times 24 is 6. So I'm finished with that equation. Now I'm going to do the same thing with this bottom equation, but since I want to eliminate the x term, I need this 9x to be a negative 3x. So in order to do that, I'm going to multiply this bottom equation by a negative 1/3. So negative 1/3 times 9x is a negative 3x. Negative 1/3 times a negative 3 is a positive y. And negative 1/3 times 18 is a negative 6. Done with this one. So now I'm going to stack and add my new equations. So we have 3x minus 3x, which is 0x. So I've eliminated the x term. But if you look, something crazy is happening here. Negative y plus y also eliminates, leaving us 0 on the left-hand side. And over here on the right, 6 minus 6 eliminates as well, leaving us 0 equals 0. No, we didn't do anything wrong. This is called an identity. When all of the variables cancel out and you're left with a true statement, it means that it doesn't matter what x value you put in, it will work. Doesn't matter what y value you put in, it will work. So basically what this is telling me is that I have the exact same two lines, just written two ways. They have every single point in common. Let's just check that theory and see if this really is an infinite solutions example. We know, let's look at the red one. We know that we had this reduced down to 3x minus y equals 6. And if we look at the tan equation, we had a negative 3x plus y equals 6. Let's put these both into y equals mx plus b and see if we really do have the same line. So over here, we can subtract 3x from both sides, giving us negative y equals negative 3x plus 6. Then we'll divide every term by a negative. So y equals 3x minus 6. And over here on the right, we'll do the same thing. We'll add 3x to both sides. We get y equals 3x plus 6. Oh, right there. I dropped a negative right here. So this would actually be minus 6. There we go. So we have y equals 3x minus 6 here and here. So yes, we have the exact same line. It was just described a couple different ways, so we didn't catch it at first. But we did get a chance to talk about an identity. Remember, an identity means any x and y value will work as a solution. An identity happens when all of the variables disappear and you're left with a true statement.